last example to take a look at. So we've talked about the demand, and now we've got the supply included in here. So here's the demand that we were looking at before, and now we've got a formula for the supply over here. And notice, right, for the supply, the slope is positive because higher price means more incentive for producers to produce more. So let's say, just randomly picking a price, what would happen if we randomly say, let's set the price at $100. So for, say, the demand, if I set the price equal to 100, and since we have two queues here, we have a queue for supply and we have a queue for demand, I'm going to just put a little subscript of a D on that. So I could solve this equation for Q sub D. And if you allow me to do that a little quickly, you can verify my solution here. Everyone got it? I think this winds up being 32.6. Okay, so by subtracting the 198 and then dividing by -3. So this would tell me, okay, if we charge $100, there's going to be 32, 33 units demanded. And for the supply side, if we set the price at 100, we can then figure out what would be the quantity supplied at that point. So we could subtract the 44 from both sides. So that would be like 56 is equal to 11Q, and then dividing by 11 would give us a little bit more than 5. Okay, so all of this is to say, I want to figure out what is the market going to do if I just picked a random price of $100. So I can see that 32 some odd people are going to want this item, and they go to this store and there's 5 of them at the store. So you're the store, you've got 32 people that want to buy 5 things. What are you likely to do? Yeah, you're going to say, this is great. We've got 32 people willing to pay $5, willing to pay $100. Who would pay $101? Who's going to pay $102? And you start to weed out some of the people. And so the price is going to go up. That's right. So when we have over here, this would be an example of a shortage. Right? Demand is more than the supply. So we don't have enough things. So the price goes up. And you could make the same sort of argument about what happens when the price is too low. Or excuse me, when the price is too high. Like if they were to charge $1,000 or something like this for it, and then they realize nobody wants it, then it goes on sale, and it goes on sale, and it goes on sale again. So when you have too much stuff, that's when the price comes down. So the equilibrium is going to be, what is going to be the price when the quantity demanded exactly equals the quantity supplied. So let me come over to a fresh slide over here. So we've got the, let me get these equations. So the supply, or excuse me, the demand was 198 minus 3Q, and the supply was that P was 44 plus 11Q. So the equilibrium is going to be the intersection, just like it was with the revenue and the cost. We want to find the intersection of the supply and the demand. So we set supply equal to demand. And in this case, we solve for Q. So I would get 198 minus 3Q, and I set that equal to 44 plus 11Q. And then we solve. So for example, let me subtract 44 from both sides. And then I can add the 3Q to both sides. So I want to get all of my Q's on the same side and everything without a Q on the other side. And then we divide by 14. So this tells me what the equilibrium quantity demanded supplied would be. But let's say what we want to find is what's the price going to be? What price is the market going to determine this good should be sold for? So I guess, sorry, my first question is, I've been talking. Any questions about why we want to set supply and demand equal to each other, first of all? And then all of this algebra to get that makes sense. So how can I figure out what the corresponding price is now?
You plug it back into any of the equations.
That's right. I can take this 11 and plug it in over here, or I can take it and plug it in over here. And it doesn't matter which one, because this was the value of Q that made them equal to each other. So if we solve this correctly, and if you want to check it, you can check if I plug 11 into the supply and into the demand, do I get the same thing back? And in this case, you do. You get that the equilibrium price is going to be $165. And at that price, 11 units are going to be supplied and demanded. And so the picture, just to really informally draw this out, is we had our demand over here, and now we've got a supply over here. And this point that we found, mark it in red, this point over here is the 11 units that were demanded when the price was 165. So we found the intersection point of those two lines. So kind of the mathematics that we use here is the same mathematics really that we use with the revenue and the cost, but it's a different context. So we just want to make sure that we interpret the components of the formulas correctly.